We are back for the last video for the trigonometry unit in Foundations in Pre-Cal 10. We're on page 108 in section 2.7 or lesson 2.7. So now we are looking at problems in 3 dimensions. So these can be hard. If you're having trouble with these, I have some sponges in class that we can take and we can cut them to match sometimes what's going on in the question. And that can be really helpful if you're having trouble visualizing it. The other really important tip for these ones is that once you figure out what's going on, sketch a 2-dimensional representation of the triangle that we're specifically trying to find information about. Okay, and we'll do an example of that when we get to that. All right, so the first thing it says, we got we've got a solid. The solid was formed from a rectangular prism. Now, a rectangular prism is just a box, okay? And we removed a wedge from it, and we were left with HD, so that's this side, equals HC, and those are both 5. So I'm just going to label those, put those on there so that I can see it. And EA equals FB, those are both 2. So that one's 2 and that one's 2. And AD, so this is like the side of the original box, is 6. And AB is 8. So notice that that does not look like it's to scale, does it? No. Okay, now let's throw some colors in here. Let's just change those last 2 that I did. Because if I make this one, I'll do this one in blue. So AD, that AD was 6. And then this side is 6 because it was a box, right? Those 2 sides are the same. And AB is 8. And then the back of the box is 8. But this top up here is also 8. And this one here is 8. All right. But these sides are not because that's a slope. We don't know what those ones are. Okay. All right. Let's name the 4 rectangles in the diagram. Okay. Well, we have the bottom. We have A, B, C, D. So that's like the bottom of the box. And then we have the top surface. So E, F, G, H. And then we have this front rectangle, A, B, F, E. And it doesn't matter which letter you start on, but you have to follow them in order. Whether you go clockwise or counterclockwise, you have to stay in that order. And then we have the rectangle at the back, which I'm going to call CDHG. CDHG. Okay, so those are our 4 rectangles. And then calculate the measure of angle HEA. So that's HEA. So I'm going to draw, that's like the side profile of our wedge. So I'm going to draw it from this side here. Okay, so it's higher at the back, and then it comes down, and then it's like that. Okay, so let's put the letters on it so we know where this came from. Okay, so that's H, that's D, that's E, and that's A. So I know that EA is 2, and AD is 6, and HD is 5. And we are asked to find angle HEA. Now, HEA is not part of a triangle. At least it's not part of a right triangle. So it's not really useful to us as it is right now. But I could draw another, I want to make that more visible. Let's do that in a different color. Let's do that in the green. I could draw this here, and if I label this angle theta, I know that I'm making this angle 90. Okay, so if I make that angle 90, then this length is 2 and this length is 3. And this, because this was a rectangular prism, those are both 90-degree angles. Right, those are hard to draw. This is a 90-degree angle, and this is a 90-degree angle, and this is a 90-degree angle. It's hard to draw in a 3-dimensional drawing. Okay, so I can say from this that angle HEA is going to be 90 plus my theta. So it's going to be 90 plus something, and that's going to equal something degrees. Okay, and then I can find out theta. So looking at theta, there's my angle of interest, my hypotenuse, my opposite, which is, my opposite, which is 3, and my adjacent, which is actually 6. So I'm looking at tan. So I'm going to find theta here, and I've got tan theta is opposite over adjacent, so tan theta is 3 over 6. So theta is going to be 30.963755653. And since I'm going to the nearest degree, I'm just going to round that here. It's going to be 30 point, oops, it's going to be 31, sorry. It's going to be 31 degrees, oops. 31. So if I add those together, I get 121 degrees. Okay, so there's how big angle HEA is. All right, now we're not finished. We got 2 more questions to do with this setup. So they're on the next page. So we're going to be flipping back and forth from one page to the next. Calculate the measure of angle HFE to the nearest degree. So, you know, I think I'm going to do, oops. Okay, just like magic, I now have a snip of that, of the original drawing. Okay, so we need to calculate the measure of HFE. So HF, where's the E? E, oh, HFE to the nearest degree. Oh, so we're looking at the top surface of this. Okay, so we can, let's draw that top surface. Okay, so this is H, and this is G, and this is F. Oops, that was not very well written. F, and this is E, and we want angle HFE, so we're looking for this theta. And what do we know? We know that EF is 8, and we do not know what that side is, do we? So how are we going to find that? Well, we know that we need that, so let's give it a letter. Let's call it X. Okay, so we need to find X. So we need EH, which is X. We don't know what that is. So let's, looking back at the diagram, EH, that's, if we look at the side, actually, if we look up to this triangle that we had here, we can maybe find EH. So let's redraw that side triangle. There's lots of steps in these questions. So let's draw, let's do this. So we've got, looking at the side, I just care about that triangle now. So this is 3, and this is 6, and this is X. And let's just label this. This is H, and this is E. And this doesn't really have a label, but it's somewhere on the HD line. We want to do that. And this is 2, but that's the 3, and that's a right angle. And that's my X. I hope you're seeing that labeling things and writing them out neatly and keeping your work organized is really going to help you. Okay, so how can we find X? Well, we can use Pythagoras. We do know, we do have a measure for this angle, but why would we use it if we don't need to? We can use raw data and we can use Pythagoras. So we know that 3 squared plus 6 squared equals X squared. So 45 equals X squared, so X equals root 45. And I'm just going to keep that as root 45, just leave as root 45. Don't bother simplifying it or getting a decimal approximation or anything like that for it. It's easier to write root 45 than it is to write anything else. So now we're back up here, and we can continue on with this because now we have a value for x. X equals root 45. And so now we want theta, and so we're going to use tangent. So tan theta equals opposite over adjacent. So tan theta is root 45 over 8. So theta equals 39.98. Something else. So the nearest degree, angle HFE equals 40 degrees. All right. I just want to fix this over here because it's just because of the tablet that I use. It doesn't always pick up when I've picked up my pen. Okay, so we've got that angle is 40 degrees. Does that seem reasonable? Yeah, it does. Yeah. Because this is not to scale, right? This is not going to be much longer than 6 this side. In fact, we could check that if we actually take the square root of 45, which I didn't do. Root 45 is 6.7. And that makes sense. If you look at the drawing, since it's, here, if we go back to here, since this side is 6, this is going to be a bit more than 6. 6.7, yeah, that's in the ballpark. Okay, last question. Calculate the measure of angle HBD. Okay, so HBD, that's cutting the shape in half. Can you see that? Okay, so let's draw HBD, and I'm drawing it from where I'm sitting. So I've got H is, this is H, and this is D, and B. So I know that this is 5 because that's given. I'm actually going to move this over a bit and oops. This is given. I'm going to write that down. We were given that is 5. And I want the measure of HBD, so I'm looking for theta. That's my unknown. And is it easier for me to find the distance from H to B or H to D? I think that the HD is going to be, or sorry, the DB is going to be easier to find. But you know what, let's just set this. So if I know that that's what's going to be easier to find, I'm going to label that as X, and I'm going to do this work first. Up here, I got to here and I'm like, oh, I need to find what X is. So I went and found X and then I continued on. This time I'm going to do it differently. I'm going to set this up and then I'm going to find X and come back and fill in my spaces. So I know that I'm going to use tan. So tan theta is opposite over adjacent. So tan theta is going to be 5 over X. So tan theta is going to be 5 over something that I don't know yet. But now I'm going to go find it. I'm going to come over here and I'm going to find X. So that equals dB. And I do have a box on the bottom of my box that I can use. So this is D and this is A and this is B. And since I know that DA is 6 and AB is 8, this is my X. I can use Pythagoras. So X squared equals 6 squared plus 8 squared. So X squared is 100 and X is exactly 10. So I can take my 10 and I can put it in here. And I've kind of run out of space here. This is the disadvantage of doing this. But if I take this and I'm just gonna come over here and down here, that my tan theta equals 5 over 10. So theta equals 27 degrees. Okay, so that's the answer to that measure of HBD is 27 degrees. All right, and that's the end of the lessons for the trig unit. Yay! Bye.